Good day, students. Today we're going to look at the solution to number 1 on page 135 of your booklet. That's book 1, chapter 2, page 135. It's in practice 5. And in this one we're asked to solve a system of linear inequalities by graphing. Now we know that when we did the linear inequalities separately, we got a half plane. So when we do a system, two or more inequalities together, we're looking for where all the half planes overlap, where all the shaded areas overlap. Now the last time we tackled this, we did it with slope-intercept method, so let's do the same thing. Let's look at now putting the first inequality into that form. So I move 2x to the other side. Right, I take 2x and bring it over here, and of course that will change the sign. I will have now y greater than negative 2x plus 2. So there, one quick step, we have it in slope-intercept form. Now when it's an inequality, we look at four things. Well, we look at the slope, so m1 here is negative 2. Or we can call it negative 2 over 1 if you will, giving us a rise of 2, a run of 1, negative slope, so it slants to the left. The second thing we can tell is the y-intercept. The y-intercept here, we'll call it b1, is equal to positive 2. But when it's an inequality, we can tell two more things, and that is we look at our sign, and our sign is a greater than sign. And when it's greater than, it tells us two things. There's no equal sign. So if it's just greater than, then we are going to have a dotted or broken boundary line. Alright, that's the line that divides it into half planes. We call it a boundary line. And the second thing the greater than sign tells us is we shade above, or to the right if it's a vertical line. So how many things do you see we can look? Right, we told the slope, 1. We got the y-intercept. We know it's a dotted boundary line, and we know where to shade. So it tells us four things. Alright, so let's tackle that one first. Let's do that separately. So the first thing we're going to do is find the y-intercept, which is positive 2. There it is, 2. And from that point we use our slope, which is a rise of 2, and it's left, so I'm going to go 1, or I can go down 2 and over 1, same thing. And I'll put in several of those indicators. There. Now, before you sketch that line, remember to check whether it's a solid line or a broken line. In this case, it's just greater than, there's no equal sign. So it's a broken line. So I'll sketch that now as a broken line. So there's my line. Now, so there's my boundary line. Now, in this case, I have to shade above. Now, you just take your pencil or a pen and just shade above lightly, right? So I'll just indicate that we're up in this area right here. Okay, so we're in this region somewhere. Okay, now repeat the process for the other one. Okay, repeat that process for the other equation or inequality. So 2x subtract y is less than 6. Alright, repeat the process. So negative y is less than, bring the 2x over, negative 2x plus 6. Now we have to divide the inequality by the coefficient, right, of the y term. The coefficient, when there's none, is understood to be -1. So we are now going to divide each one of these by -1. Now you'll notice I left a blank there for the inequality sign, because it's very important when you divide or multiply an inequality by a negative number. When you divide or multiply an inequality by a negative number, you must change the inequality sign. So therefore I must change this sign. That's why I left it blank, just to make sure you realize we have to change this sign when we divide by a negative number. Now, you only do that if you divide by a negative number. If you divide by positive, your sign does not change. And I'm sure your teacher discussed this with you in your class, why that is so. So we end up with y greater than positive, negative over negative, so it's positive 2 over 1x minus 6. So now let's look at the four things that tells us. It tells us, first of all, the slope. So my slope, we'll call it m2, is 2 over 1. It tells us the y-intercept, b2, we'll call that's negative 6. And because it's a greater than sign, it tells us what? So this greater than sign right here tells us we have a broken or dotted boundary line again, and we are now greater than. Because it's greater than, it tells us to shade above. Okay, so let's look at that now. Graph the y-intercept of negative 6 on right here with a negative 6 positive slope, so up 2 over 1, up 2 over 1, up 2 over 1, and so on. And again, we use a broken or dashed or dotted boundary line, whatever way you want to say it. So I'm indicating that line now by sketching it. Alright, now, so we are asked to shade above that. So above that, of course, will be in this region here. Alright. So it's above this line. Now, where do the two shaded areas overlap? That's your solution. So take a different color pencil or pen and shade in that a little on the darker side. Alright? So we're gonna take, say, we'll take a black marker here and we'll indicate that this is our solution. Our solution is where the two areas overlap. So the dark or the black marker there is now shading that area. That's your solution. And you can check that, of course, by picking a test point from that area. So what I want to do now is pick a test point from this area. Okay, what would a test point be? Well, you can see there's several points we can pick. I'm going to pick something on the x-axis here. I'm going to pick right here, which looks to be 2, 0. Now you could pick several, 4, 4, 3, 3 or there, anything, 6, 5, anything in that area, right? So I'm going to pick a test point of 2, 0. Now when you pick a test point, make sure you substitute it back into the original equation. Okay? So I go back to the original inequalities, because we changed signs, and if we've made a mistake, we'll pick it up here by checking back in the original. So there are my two original inequalities. So I go right back to the original ones we started with, right? Now x is 2, so I'm putting in 2 times 2 plus 0 should be greater than 2. 4 plus 0 greater than 2. Is that a true statement? Is 4 greater than 2? Yes, indeed. 4 greater than 2. We have a true statement. So that one worked. Let's try the next one now. 2 times 2 subtract 0 should be less than 6. 4 subtract 0 less than 6. Is 4 less than 6? That's also a true statement. Therefore, I know that is the solution. So that's a complete solution. Now if you want to check it on your graphing calculator, you can do that as well. Okay, now how do you graph these on your graphing calculator? Well, the first thing you do is have to find graphing, and it's under the apps, graphing inequality. And if you scroll down, it's several steps down. I can't remember how many, but it's called inequality. Let's see. Oh, there it is. I just passed it. Let me go back. Inequality Z. Inequal Z. Okay, so hit enter twice, and you'll notice now it brings up all the inequalities signs, of course, right above these gray buttons. So if I want to plot, in this case, the first one, now it has to be in slope-intercept form. Remember, the first one was y greater than negative 2x plus 2. So I need to change it to greater than. So I hit this gray button. Oops, let me go back. Alright. So if I want this now, I hit at alpha, see alpha, the green button, alpha greater than, so that's the trace. So alpha trace will change it to greater than. See the little indicator there showing greater than. And then you just type your equation. It's minus 2x. So we type now minus, okay, you just move over here, minus 2x, oh, wait, no, sorry, minus 2x plus 2, I believe we had the first one, wasn't it? Plus 2. Oh, I forgot my x. Let me go back and get that. Minus 2x plus, okay, 2. Alright, go down to your next one. Now if you want to see that, you can just hit the graph button to see it. Oops, I have a mistake here. Let's go find it. Go to the arrow. Oh, it's negatives 2x plus 2 instead of. Now, so it's shading that. That's the first one we did, remember? Okay, so go back to y equals, and we'll scroll down to the next one, and this one was greater than 2x minus 6. So again, we hit alpha trace to change it to greater than, then arrow over to and the next line and type in 2x subtract 6, and we'll graph that as well. So you see now where they overlap, the two. There's the first one, and now it's overlapping. So this shaded region right here is the same shaded region we had, is the solution to your graph. Okay, so that's the solution to number 1 on page 135 of your book 2.